In this video, I'll be going through the question you see on the screen here from the 2023 Leaving Cert Higher Level Maths Paper 2. If you're looking for a different question from this paper, check out the description below. There should be a playlist there. And if you're looking for a different paper entirely, have a look around on my channel. I'll be doing all this on a whiteboard, hopefully like you're used to your teacher doing. But we are on YouTube, so take advantage of the features there. Watch it at half speed or double speed, and certainly pause and try the question first. If you find this video or any of my videos useful, I would greatly appreciate a like or subscribe, but what helps especially is sharing it with a friend that might be doing the Leaving Cert this year or next. Question 2, part A, asks you to prove a trigonomic identity. One of the many that's in your book, and one of the 7 or 8, is it, that you are required to be able to prove. Now before I do this, I would say I don't like doing these because I don't like how they're done in the exam. I think they should be actually harder, which I know you don't want to hear. But every trigonomic identity can be proven, all starting with some very simple things, and it's all like built on like a few simple blocks, and all of these can be built up, and you end up with loads and loads of proofs and stuff. So everything in your book can be proven. But what they're doing is they're asking you to prove this one block all the way up here. And I think to prove this, you should have to prove everything to get there. Now it's not actually that many. It's only maybe 2 or 3 steps to get there. But they don't require that. And this is what confuses me. They let you use some of the other ones. And I'm not sure they tell you when you do. Honestly, the best way to do this is probably just to not memorize it, but to study all these proofs, to know exactly what you're going to use. And the trick in this one is they let you use, and there's other ways to do this, because you can go different paths through all these blocks. But the most famous way would be, you're allowed to use the fact that cosine A minus B, this is from your book, is equal to, let's say, cosine A cosine B plus sine A sine B. So that's why I don't like these, because if I'm proving this, why don't I have to prove this? Still, okay, we'll assume we know this. Okay, let's start solving it. The first trick to do is sine A plus B is equal to cosine 90 minus A plus B. Now, again, here's something we're using that I'm not going to prove, but I will prove it to you guys because it's quite easy and short. This just comes from the fact that sine A equals cosine 90 minus A. And this is quite an easy one to show. You get a right angle triangle. If we have an angle here, A, this is 90 degrees. That means this angle up here is 90 minus A. That's where we get the A and the 90 minus A. And also we know the sine is equal to the opposite over the hypotenuse. And we know cosine is equal to his adjacent over the hypotenuse. They're both the same. So that's where we get this bit of information from. And that's your first step to solving this. Then let's get tricky here. We'll change cosine, change some of these numbers around. So it's 90 minus A, and then minus times this would be minus a B. These are the same things, yeah? And by the same, by this one we're allowed to use cosine something minus something. We have something minus something. We can write this line here. So let's write it over here. Give myself plenty of room. I'm writing cosine A. So that's cosine this first angle. That's 90 minus A. Times cosine of whatever's here. And in this case it is B. Plus sine of whatever's here. 90 minus A. And then, sine of B. Now, once again, 90 minus A. 90 minus A is the same as sine A. And it's the same the other way around. Sine of 90 minus A is the same as cosine, because when I said A here is this, the same works the other way. So I can change this cosine 90 minus A into just sine A. And cosine B says cosine B. Sine 90 minus A turns into cosine A. And sine B says sine B. And that is what you were asked to solve in the first place. So that's the proof to this. And there's about 6 or 7 other ones that are all equally annoying to me because we assume knowledge each time. But still, you have to do the exam. I advise you, look up all of these. Every book has them. All teachers teach them. They do 1, 2, 3 classes on it. So just practice, study them. Don't think of it as memorizing everything. Think of it as just memorizing 1 or 2 steps. Again, you don't even memorize this. It's all in your book. Just, this is what I do. This is what I do. So it's 2 things to remember here. It's to use this formula and to use this fact. And it all falls apart from there. B just wants you to use the formula in part A, this first line here, and without using a calculator, to find sine 75. Now, without using a calculator, we're going to need to use some simple numbers. I can't do sine 75 in my head, but I can do sine 30, sine 45, sine 60, sine 90, all of those. I can do them, well, not quite in my head. I can read it from a page. But actually you can even figure them out. You can prove each of those without too much trouble. So still, we don't have to. We'll use the page. So 75 thankfully does break up into sine 30, something we know from our tables, plus 45, something we know. So we can use that and break it up like this. It's sine 30 cosine 45 plus cosine 30 sine 45, and we can just look all these up and let me run through them here. This will be a half multiplied by 1 over square root of 2 plus cosine 30 is square root of 3 over just 2, okay, and sine 45 is the same, isn't it? 1 over square root of 2. And they want you to put your answer in Cert form. This isn't too bad. I think they might even give you the marks for that. But we can clean some of this up. Let's see. Both bottom rows are the same. So we have 1 plus square root of 3 all over 2 square root of 2. Again, you could leave it like that. I like to get the square roots off the bottom. So I'd multiply everyone by square root 2. So the bottom multiplied by square root 2, it will turn into 2 times 2. So we get a 4 on the bottom. The top multiplied by square root 2, we'd get square root 2 here and square root 6 here. Again, I think this is full marks. How I would write it though is I'd put the 4 into both. 1 over 4 square root 2, that's Cert form for me, plus 1 over 4 square root of 6. Anyway, that'd be my final answer, but I'm fairly sure you get full marks for pretty much all of that there. Okay, let me clean this off and we'll do the next part. Okay, for part C, they give us this question here. Sine t is equal sine 2t. And they want us to find all possible solutions between 0 and 360. Now, I'm going to draw a picture. I always draw a picture whenever I can, and I advise you do too. In fact, there's 5 answers, just a spoiler. There's 5 answers to this question. I'm going to find 3 of them just by drawing a picture. So it is quite useful, and it's going to help us as we go along. Draw a picture here. I'm going to draw the left side, sine t, and that should be straightforward to draw, something like that. Then I'm going to draw the right side. If you're good at drawing it, brilliant. Basically, when the number's multiplied, it gets shrunk in, and you need to know this for other parts. And when it's divided in here, it gets stretched out. But still, I like to do it just slowly each time. If I put for the left side, if I put 0 in, and think of putting it in a calculator, sine 0, 0, sine 90 is 1, sine 180 is 0, and so on. You could put dots here the whole way. Just do this slowly. If you're not good at remembering how they work, do it slowly. Put 0 in, 2 zeros are 0, sine 0, still that. Put 45 in, 2 45s are 90, sine of 90 is 1, so 45 will be around here. There's about 1. Put 90 in, 2 90s, 180. Sine of 180 is 0, so we get 0 here. And stay going, we'd get a dot here, here. Just remember to stay going past 360. Well, what I mean by that is you're going all the way to 360 for t. So you end up getting 2 360s. So this last one would be actually sine of 720, which is 0. But still, you can draw all these in. Now you don't have to do all those dots. But that won't get too like that. Well, yeah, I guess it would come more over like that. Anyway. So I can already see there's 5 answers to this. There's 3 very easy ones where these two guys intersect. So I already know the answer is t has to be 0. They both agree at 0. They both agree at, I should have used 2 different colours. They both agree at 180. And they both agree at 360. And then I can see there's 2 other solutions. They both agree somewhere around here. You know what, my drawing's bad because I think this should be higher than that maybe. I'm not sure, but they both seem to agree here and they both seem to agree here, although my drawing applies maybe twice there. But no, they agree once here and once up here. But how do we find that? We'll have to do it the hard way, the maths way. And you could get away without doing this, but still. Okay, let me assume we don't have that and let's do it the hard way. Let's start expanding out. Can't do anything to the left. Let's expand the right hand side. There's 2 choices for sine 2a or sine 2x or sine 2t. In your formula book this is. One choice has like tan squared and stuff like that, which will work out eventually, I think. I'm fairly sure you'll end up getting a quadratic or something. But there's a much easier one. So the left side says sine t. There's a formula for sine of 2 times something. We'll turn it into 2 times sine of t cosine t. And we just try and solve this. Be careful, you might be tempted to divide both sides by sine t. And you can do that. You'll get 2 answers eventually. But you won't get these 3 answers. So it's okay to do that now if you know what you're doing, because you already have these 3 answers. But just be careful is what I mean by that, because you would potentially be dividing by 0, because sine does equal 0 at 3 points. So let's not do that. We won't do it that way. We'll take this from both sides. 2 sine t cosine t minus sine t, and we'll factorize it. We'll take sine t out of both of these terms. Sine t goes into this 2 cosine t, and it goes into this once. So we get this factorization. This gives two answers. It gives sine t equals 0 is one possible. So 2 things multiplied against 0, one of them has to be 0. Or the other possibility is 2 cosine t is equal to 1, or cosine t is equal to a half. And these give us 2 things to solve. Put this in a calculator, or like inverse sine of 0 in a calculator. It'll tell you t equals 0. But we do need more answers than that, so we'll talk about that in a moment. Put this one in a calculator, you'll get t equals 60. But we do need more answers. To find them, let me just, another couple of pictures. I'll draw sine again. Your calculator only tells you the first answer. If sine equals 0, there's lots more answers, and we're looking at the world between 0 and 360. There's 3 answers. Calculator only tell you this one. You do need to give them 180 and 360. Again, we already knew those ones. 180 and 360. Next one is cosine. So we need to draw another picture. Cosine looks like that between 0 and 360. It's a half. So you get these 2 answers. Calculator give you this first answer, 60. You need to be smart enough to find this second one. 60 away from 0, it must also be 60 away from 360. So the second one is 300. Oh, 300. And they're your 5 answers, all between 0 and 360. And what you can do, just to be careful, is put them all back in. If you have an extra minute in the exam, sine 0 equals sine 0, perfect. Sine 180 does equal sine 360. Sine 360 does equal sine 720. Sine 60 does equal sine 120. And sine 300 does equal sine 600. Everything works for that. Okay, thank you for watching. If you have any follow-up questions, let me know in the comments. I'll do my best to answer. Have a great day and see you next time.